Hey everyone, welcome to my channel. If you are interested in speaker design and improving sound quality, subscribe and join us. In this video, we're going to create a fixed template to design the transmission line of our desired drivers. Akabak. The link to this free software is available in the description. Watch this tutorial till the end and practice. Akabak generates accurate results and takes into account many aspects of speaker design, while the other software may not. Double-click on this area. Select nodes and name it horn. Later, you can import all the required points of the horns into the software here. For a better understanding, pay attention to these photos and how the horn is completed. Then create another one for the enclosure of the speaker. Just do all the steps like in this tutorial so that you don't have any problem in the next tutorials. We'll compare Akabak with a software program to find their differences and their pros and cons. Now, it's time to create two interfaces, one to connect the enclosure to the horn, and another for the horn to the outside space. Name them int1 and int2. You can name them whatever you want, but to find all the parts quickly, these names are recommended. To create a damped box and a damped horn, we need two wall impedances, one for a piece of the enclosure and another for a piece of the horn. The green areas. It's better to define two different colors for the horn and the enclosure. I select green for the enclosure and yellow for the horn. If you want to have a background of Akabak, watch these series to be familiar with many parts of this software. One of the most important parts is to define suitable units for the template. Follow this direction and change them like this. After that, click on the BEM tab and create some subdomains. The first is for outer space. Name it outside. Select exterior because it's related to the outer space. After that, create two subdomains for the horn and the enclosure. The inner walls of the horn and the enclosure are distinct from the outer space, and their subdomains could not be exterior. Make them interior, and do all the steps as well. Since the enclosure is distinct from the horn, we need one connection or interface to connect them, and another to connect both the horn and the enclosure to the outer space. Something like this. On the Parameters tab, connect the enclosure to the horn like this. Do it to connect the whole to the outer space. As you can see, the subdomains can connect to each other simply. Fostex drivers are usually recommended to be used with the transmission line. It's good to start our first simulating project with them. This is the specs of FE126NB2. Select diaphragm, then the enclosure subdomain to import the rear side of the diaphragm. On the Dimension tab, select Outer Dimension. This is the most important part of importing a desired driver dimensions into any software. We need the effective area or effective radius of the cone, including the surround rubber. In this datasheet, it's 4.6 centimeters. Click on Cone Rear tab. This distance is about 6.1 centimeters, and if we approximate the height of the cone or this part, it'll be about 2.5 centimeters. According to the driver specs, the voice coil diameter, or DVC, is 2 centimeters. The inner part corresponds to the front of the cone. With a simple approximation, choose the height of the dust cap as 0.5 centimeter and this part as 2 centimeters, and 3 centimeters for DD1. On the Meshing tab, select Bifurcation for this and change this combo box to value. For the driver or sound source, the mesh size should be as small as enough. If after the calculation the shape is destroyed, we need to select a smaller size of the mesh. Name it Rear as the rear side of the cone. Select with baffle. Now, you can see the rear cone, but it is not finished. Now copy the diaphragm and paste it into the outside subdomain. Name it Front and click on Apply. The driver shape is completed and is similar to its datasheet. Now, we need some elements to connect the created nodes. You'll find out what I say in the next videos. We need one element for the outside subdomain. The horn subdomain needs two ones. One for the horn walls without damping, and another for its damped walls. Do the same as the horn for the enclosure. Another way to rename the components is to click on them. Do the same to have an organized template file. After renaming, double-click the baffle element and on Meshing tab, at the edge length section, select by value. Since the transmission line or folded horn is generally constructed for low frequencies, a mesh size of about 15 centimeters is a good value. The higher the considered frequency, the smaller the mesh size. You can choose very small mesh sizes, but the calculation will be very slow after running. Do it again for the horn. Considering two elements for the horn, the Boundaries tab, we need to define a wall impedance for one of them. This section connects the related elements to wall impedances. The second element of the enclosure also needs a wall impedance. We need to create two nodes for the two interfaces. All steps are the same as before, but those don't need the wall impedance. This video ends here. In the next parts, we're going to complete all the parts of this template and reach a structure like this.